Hi, my name is Brandon Graisley. I'm a high school computer science teacher. We're going to learn about conditional statements and Booleans, and we're going to use leap year testing as an example to do that. So knowing whether a year is a leap year is a little bit complicated. There are 3 rules. It has to be a multiple of 4, but it can't be a multiple of 100 unless it's also a multiple of 400. So let's look at some examples. Down the left-hand side, 2012 was a leap year. It's a multiple of 4, but not of 100. 1904, 1788, all multiples of 4. And the year 2000 is a multiple of 4. It's also a multiple of 100, which would be bad, except it's a multiple of 400, so that's good. In the non-leap year category, 1999 was not a leap year. 2015, those are not multiples of 4. 1900 is a multiple of 4, but it's also a multiple of 100. And not a multiple of 400, so not a leap year. Same with 2300. So we need to know how to handle this idea of multiples. So a whole number, let's call it x, is a multiple of another whole number, y, or we say it's divisible by y, if x can be divided by y with no remainder, or that is a remainder of 0. So for example, 15 divided by 3 is exactly 5 with a remainder of 0, no remainder. But 16 divided by 3 is 5 with a remainder of 1. So it's not exactly 5, it's a little bit more, and the remainder tells us that it is not divisible. So in Java, we have an operator for this. The remainder operator is the percent symbol, which is really called the modulus operator, or mod for short. So we would type something like 15 mod 3, and that would give us the value 0. That expression 15 mod 3, 15% sine 3, is equal to 0. 16 mod 3 gives us a value of 1, and so we can tell right away that 15 is divisible by 3 and 16 is not divisible by 3. So how do we test whether something like a year is divisible by a variety of different values? Well, each one of these statements can show up in our program. Year mod 4 has to be equal to 0. We want year mod 100 to not be equal to 0, so we'll have to figure that out. And year mod 400 can be equal to 0. Notice that we're using the double equal sign. That's a comparison that checks whether something is equal. If you only have a single equal sign, that's the assignment operator. And you're saying something is going to become equal to 0, which wouldn't make sense in this case. Okay, let's go over to a program that I've started, and let's write the logic for figuring out whether a year is a leap year. Okay, here is my interface for the Android app I've started working on. A place to enter a year, that is an edit text, a big button, followed by there's what will be an invisible text view, which gives the answer once the user has typed something in and clicked on the button. Let's go over to the Java code. I have the 2 user interface components there, the text view and the edit text that's at the top. There's the text view, there's the edit text, all initialized in the onCreate method. And I've also written the beginning of a method, check leap year, that's attached to the button, so that when the button is clicked, this method will run. So let's go back and look at our rules for leap years, and then we'll start to implement them. A leap year is a multiple of 4, not a multiple of 100 though, unless it's also a multiple of 400. So what we can do is start checking this with some if statements once we've gathered the year from the user. When we get a value like a number from the user, we need to use a try block. We're going to try to get the number, and if we're unsuccessful, we're going to catch the number format exception. And I usually put that variable name as a little short form of the exception type, and we'll do something in there in a minute. So that's going to happen if the user basically doesn't type anything in, because I used a number type edit text in my user interface. So let's first of all get the number from the user. So the int, let's call it year, will be equal to integer.parseInt, and we want to go to the edit text, which is called year et, get the text from it, turn it into a string. Okay, that will give us the string value turned into an integer to see, is this a leap year or not? Well, we can do this with a series of if statements, if, else if, and so on. The order in which you do this matters quite a bit. So there are options, multiple options, but you have to be thoughtful about which order you put things in. So for example, let's say, what if the year mod 4 is equal to 0. So let's have that as a starting point. That's a good start, but does not guarantee that you have a leap year. So I'm going to write a little else down here. If the year is not divisible by 4, then we have not a leap year. We're going to handle that in a minute. So I'm just going to put a comment there for now. So if the year is divisible by 4, it might be a leap year, but it won't be if it's divisible by exactly 100 but not 400. So we need another if statement then. Let's try this. If the year is divisible by 100, that's the year mod 100 is equal to 0. So this is now divisible by 100. We have to check though, what about 400? Because if it's divisible by 400, it's still a leap year. Otherwise it's not. Okay, so if the year, so I'm inside of the 100 divisibility block now. If the year is divisible by 400, written again with the mod operator, then it is a leap year. Otherwise, it's not a leap year. Okay, whew. So we've handled that special case now. So if the year was divisible by 100, we had to do some extra fancy stuff. Otherwise, it's divisible, I did it again, divisible by 4, but not 100. So that's fine. And so it's a leap year. Wow, getting quite complicated. So we have 1, 2, 3, 4 places where we need to sort of tell the user whether it was a leap year or not. Now I'm going to do this with the output text view. I'm going to set the text to, I'm going to put the year, and then I'm going to say is a leap year. I'll put a little smiley face. So notice that I put a little space right there. That way it'll print out the year number, let's say 2000, and then a space is a leap year. I'm going to copy this for my not a leap year one, and I'll say is not, is a not leap year, is not a leap year, frowny face. And then this one will be good. And then let me grab my frowny face one again for this one. All right, so we have all kinds of different pathways to get here. So this is kind of complicated, and we are going to simplify it in a bit. Before we test this, though, let's check out what happens if the user enters nothing at all. Output tv.setText. Please enter a year. All right, let's try it. Okay, we're ready to enter a year. Let's try, well, the current year, as I'm recording this, is 2020. Is it a leap year? Hey, it is a leap year. Now let's just see what sequence of if statements and so on did we go through. Was the year divisible by 4? Yes, it was. Was it divisible by 100? No, so it skipped all the way down here to this else. That year was a leap year. So that line 44 was the one that ran here. Okay, let's try next year. Will next year be a leap year? It is not a leap year. Okay, so that was if the year was divisible by 4. It was not, so we hopped down to this else down here. Now let's test these tricky ones. How about the year 1900? That should not be a leap year. Let's see. It is not a leap year. So divisible by 4, yes. Divisible by 100, yes. So we had to run this code. Was it divisible by 400? 1900 is not. So we ran this else block, running that line of code. Okay, let's also try 2000. Was it a leap year? Yes, it was. Divisible by 4, also divisible by 100, but also divisible by 400. So this line of code, 34, is the one that runs. Okay, the only other thing to test is the catch condition where the user doesn't enter a year. I put in nothing and we ended up with the error message that we wanted. Okay, now let's look back at some of the details of how these conditionals work, and then we'll return here to improve this program to make it much shorter and more readable. So we're going to learn about how conditional operators work. Instead of using lots of ifs and else ifs and so on, we can write more complex conditional statements to combine these blocks when they're going to do the same thing. So let's look at the first one. It's the AND operator, and for each of these there's two. and I'll explain that in just a moment, but you can use 1 or 2 ampersands, that's that symbol, Shift 7 on most keyboards. So for example, let's say you were trying to find out, is a person a teenager between 13 and 19? So we can have two conditions: their age is greater than 12 and their age is less than 20. Both of them have to be true. For example, if someone's age was 40, that is greater than 12, but they're not a teenager. So both conditions have to be true for us to say that that person is a teenager, both greater than 12, and less than 20. Another way to think about this is to use the OR operator. That's the vertical line or pipe. It looks kind of like a tall, skinny colon on a lot of keyboards, usually nearby the backspace key. It's directly under the backspace key on my keyboard, along with the backslash key. Once again, you can use 1 or 2 of these. They're called pipes. If the age is less than 13 or greater than 19, then we would say they're not a teenager. So my AND I used as a way to determine whether somebody was a teenager. The OR I used to find out if somebody was not a teenager. The NOT operator will change something, will flip a true and a false. So for example here, I can check to see, is my age not equal to your age? You can see that's the opposite of using the two equals signs. The equals equals would compare to see if we are the same age. This will compare to see if we are not the same age. If we're not the same age, this statement would be true. So each of those conditional statements makes a Boolean value, makes a true value or a false value. So we can actually store those values, and that can be very helpful. Imagine if you have an app where you need to know if somebody is a teenager throughout the app. You know their age, but you wouldn't want to compare over and over and over again to see if their age is greater than 12 and less than 20 while you're running the app. They're probably not aging that quickly. So let's store not their age, but their status as a teenager inside this variable. So if, let's say, their age was 15, that's greater than 12, and it's also less than 20, that would be true overall, and the isTeenager variable would hold the value true. And if the person was 40, it would be greater than 12, yes, but not less than 20, and so that would be false overall. isTeenager would be false. So we can use this with if statements in our programs. If isTeenager, that is, if that's true, then run some code, otherwise run some other code. Or we can flip it around using that not operator again. If they're not a teenager, if not isTeenager, run some code, otherwise run some different code. Storing Booleans is a great way to remember information about the state of your program. For example, if you want to know whether a player has ever talked to an NPC before, you can have a Boolean that keeps track of that. True, they have talked before, and false, they have not. Or whether the player has ever entered a particular building. If you want to do something special the first time they come in, you have a Boolean that says, have they entered before? False. And later when they come back, you don't do the special thing because you'll check to see if you've already done it. Okay, let's return to our app and try to simplify this long chain of ifs and else ifs by using those operators to combine these different conditional statements. I'm just going to start working up here. One of the things I noticed while I was writing this is that I had exactly the same line of code in more than one place, and that's a little red flag for myself that I'm not coding very efficiently, that I can come up with a better way to combine these cases. Okay, if the year is divisible by 400, that's kind of the easiest one, then we're great. That's fine. Now, but we're going to have some other conditions to check. I'm going to just put this inside of a set of brackets like that because I'm going to have another condition that I want afterwards. So that can be true, or we can have a different condition. Now in here, I'm going to have two different pieces to check. I want to know, is the year divisible by 4, but not divisible by 100? And so this is where I'm going to say, and the year is not divisible by. Now you can't put not divisible, but you can say the year divisible by 100 is not equal to 0. So let's look at this slowly. At the beginning here, we check to see, is the year divisible by 400? If it is, we're done, and we don't continue with the or part. But if it's not divisible by 400, let's say it's 1900, we need to consider the other possibilities. Is it divisible by 4? Yes. Okay, keep going. Is it divisible by 100? In that case, yes, it is. So is it not equal to 0? No, it isn't not equal to 0. A little bit confusing. And so this would be false for 1900, and this if block would not run. I guess I better actually write the if block, and then there's the else block. So this kind of checks all three of these conditions all at once. Now this is quite complicated, so I want you to take your time and think about it, and maybe write out some examples and trace the code yourself. What happens if I put in a number like 2200 or 2020? How does this evaluate to its true and false components? If this all works out to be true, then we want to say that the year is a leap year. And if it's not true, we want to say it's not a leap year. So let me just copy and paste those things up there. And all of this stuff can all go away. I'll just comment it out for now. So all of that code was replaced by these few lines right here. Let's run it and try it again. Okay, let's check now. Is 2020 a leap year? Yes, it is. Let's try 2000. Yes. 1999. No. 2016. Yes. And how about 1900? No, everything looks like it's working well. Okay, if you're not working in Android, then let me show you how to do the same kind of code in regular old Java taking console input. So I'm here at replit, repl.it, and I'm just working in the Java code area. Here we have a main class with this public static void main method. This is the one that will run when you run using the button up here, and the input and output happens down below with the way I have the interface set up. So you can see there's a print line statement, print hello world down below. Let's just run that to show you how it works. Everything runs down here. It's compiling, that's the Java C part, and then it runs the Java file afterwards, hello world. Okay, now let's copy our code from the Android Studio app into here, and let's see what we have to change. Okay, this line here, number 4, I can't run integer.parseInt on yearEditText.getText. Those pieces don't exist. I don't have a user interface component. Neither do I have the output text view to print stuff on the screen. So we're going to change both of those in just a minute. To do that, we're going to use a tool called a scanner. So scanner is an object in Java which allows you to take text input and it kind of chunks it up into pieces. For example, if you type in a number and press enter, it'll take that number and detect the whole thing. If you type in like 2000, it doesn't see 2000. It can find the number 2000 there, which is pretty cool. Let's use that. Let's call it scanner, and you declare it like this, new scanner, and you have to give it an input source. In our case, we're going to use system.in, which is whatever you type down at the bottom here. I probably need to run the import directly in this. Import java.util.scanner at the very top above the class. That way it's available here. Okay, so we're going to use this scanner right here. So instead we're going to say scanner.nextInt. Now, if you're writing a more complicated program, there's a bunch of validation and error checking to do, but as long as you use this and behave yourself, just type in a number and press enter, this will work fine. So the year has been captured in this integer, and now instead of output.setText, we're going to say system.out.println for line, and that's it, that's the change. System.out.println, and that prints out a new line. Okay, one last thing we're going to get an error here is the scanner is never closed. That's a resource leak. Okay, so after we're done the if statement here, we say scanner.close, stop listening for new input. Okay, let's run it and see how it goes. I forgot to put a prompt on the screen, so this computer is waiting for us to type a number in. So let's type in 1950. And it's not a leap year. Let's go back up and put in a prompt here, right at the very beginning, I suppose. System.out.print. I'm not going to do the ln part. That prints a line and kind of presses enter for you. Print will just print something on the screen. please enter a year. I put a space there to make it look nice. All right, let's try that again. That looks better. Okay, 1900. Not a leap year. Okay, let's try one that is a leap year. You'll notice I have to run the program every time. If you wanted to have multiple inputs in the scanner, there's quite a bit more to it. So we're not going to do that today. Let's try 2020. 2020 is a leap year, and we really should test those ones that are multiples of 400, like 2000. Let's try an old one, 1600. It is a leap year. Okay, so that is a quick way to get a small amount of input from the user just in the console. And once again, this is at replit, REPL.IT. So once again here, the goal is to learn about how conditional statements work, the ones that are made up of Booleans using and, not, or, and those kinds of operators. If you have any questions, of course, you can ask in the comments below, and I'll talk to you soon. Thanks.